Is there any x term? Doesn't look like it, right? So the next thing is the constant term, which is 14. And there you go. We have multiplied the polynomials, and we put it in standard form. I am quite certain everyone here is capable of doing this, right? You just have to be careful and do it one step at a time. We can all do this for sure, right? Can you tell me what the coefficients are in this one? By the way, so like this one has a sub 6 equals to 1, a sub 5 equal to 0, a sub 4 equal to 1, a sub 3 equal to 0, a sub 2 equal to minus 13, a sub 1 equal to 0, and a sub 0 equal to 14. So there's just a comment for you, by the way. If you want to, because one of the things students might be tempted to think about when I write this polynomial formula up there is like all of the coefficients have to be non-zero. But that's not the case. Like the leading term has to be non-zero, but things below that could be 0. So some of those terms don't actually have to appear. All right? It's like my solid state physics teacher said in graduate school. He's like, you know, elephant has wings? And we're like, what? He's like, you know, elephants have wings. Like, what's he talking about? He's like, yes, they're just set to 0. So like this polynomial has a linear term, it has a cubic term, it has a fifth order term. They're just set to 0. It was funny when he said it. There was something that was supposed to be 0 in another calculation he was doing, and it was absurd. It was equally absurd to me saying it here. He got more laughs, though. You guys are a tough audience. I'm going to figure it out eventually. All right. So that's multiplying polynomial. Of course, it doesn't have to be so complicated, right? We could have like x squared plus 3 times x squared, well, x minus 2, right? And you get x squared times x, right? Minus 2 times x squared plus 3 times x minus, 3 times 2, right? You're like, what order did you put those things in? I honestly don't know. When I multiply two things, I just multiply stuff. And then I ask myself the question at the end of it, did I get everything? And did I count everything twice? If you did it right, if you take m things, right, and you multiply it by n things, let's say if you take p things and you multiply it by q things, the net result should be pq terms. Like I could tell that this was legitimate after the dust settles because I multiplied 2 things by 3 things, and I had 1, 2, 3, 4, 5, 6 things. That shows me I didn't miss anything. That's a really quick thing you can do to check your calculation. Over here, I multiplied 2 things by 2 things. I had 1, 2, 3, 4 things. That gives me hope that I haven't missed something. And anyway, so we got x cubed minus 2x squared plus 3x minus 6. Hey, guess what? This one, when we multiplied, we didn't have to do any collecting, right? Because all of the different multiplications we do, they have different powers, so it's already in standard form. Finally, one last thing for today. We can talk about evaluation. So like a lot of problems in your homework are like this. So let's, suppose, I'll keep with this example right here. Let's suppose p of x equals x cubed minus 2x squared plus 3x minus 6, You could calculate what's p of 1, p of, let's say, 2 equal to. What would that mean? Yeah, replace the x with 2. That's what it means. You guys already knew. Why am I even, I don't even teach you you guys already know this stuff. I don't know why I teach you this. 2 cubed minus 2 times 2 squared plus 3 times 2 minus 6 will get you partial credit. If I ask this kind of question, I do want you to simplify it, right? So I say evaluate and simplify the answer. What does this work out to? Whoa, dude. What? Why did this happen? Check out the formula we started with, right? We could also look at p of x equal to x squared plus 3 times x minus 2, right? And if we evaluate that with 2, what happens? In other words, if x minus 2 is a factor for the polynomial, then when we plug in 2, we'll get 0. In fact, this is our ultimate goal in this chapter 4, is to understand how to factor polynomials completely, because when we do that, we know when they're going to give us back 0. And that will allow us to do what is called solve polynomial equations. That's our ultimate goal in this chapter. That's what we're working towards. But to do that, we must first understand multiplication. And so that's what we're working on at the moment. So, thanks, guys. Have a good weekend. Oh, I actually ended on time. Woohoo! I got a Thanos problem in there.